Hey guys, I wanted to make a video to go more into detail on my last video regarding the gas usage of the fishing experience with the quarter machine Floor's Lava project. So I wanted to play a quick clip from the AMA on Monday and then go from there.
You can scroll through as many transactions as you want. You'll see some go through at 71,000 with successful fishing.
So as you heard him there say, he said, you have seen successful fishing transactions go through at 71,000. Completely false. And I'm going to show you the exact factual numbers here as I pulled each and every one of them. So starting with the first fishing attempt all the way down, you're going to notice a couple of trends. First, you're going to notice that all the gas limits were pretty high. The lowest one was 178,000, and every other one has been above 200,000. Okay, the gas used has been almost all of them except for this one right here, which they somehow got extremely low gas. They've all been 140,000, and this one as well. They've all been 140,000 or above. A lot of these being in the 200,000 range because people are trying to fish multiple tokens. So I do not see anything under 100,000 gas used in a successful transaction list. So I would love to know which transactions he was referencing in that little clip. And so now what I want to do is I want to go explain to you guys how this gas works and why these successful transactions take more gas than the non-successful transactions that only take 70,000 gas. So we're going to go in and we're going to look at the contract. Give me a second here. Okay, there we go. So we're going to go and we're going to look at this contract, okay? And what we're doing is we're calling the fish function. Okay, so the fish function is right here. So when we call the fish function, what we're sending it is we're sending it an array of token IDs. So all of your token IDs get sent in as this array of numbers. The fish function then identifies the message sender and names them the sender. It then identifies the block timestamp, which is in numbers. So that's the timestamp, and the fish token equals 0. Okay, so that we'll come back to that in a little while. Required, is fishing open? So this will go check is fishing open, which is another function down below. Let me go show you this. So it'll come down here, it'll call this function, and this one actually sets the fishing open. Hold on. So it'll call this function here, and so right now it was initiated as is fishing open equals false, and so then what happens is the team comes in and says set fishing open as true, because it says only owner, which means only the owner can change this. So they set the fishing open as true with this boolean here, and then that changes is fishing open up here to true. Okay. So this is just the initialization part. It can be changed down below. Okay, so the next thing I want to go look at is in the fishing contract. So that's going to require is fishing open to equal true, and if it does not equal true, you'll get this error revert. Okay, so then require token IDs.length is less than or equal to batch limit. So let's go up here and look for batch limit. So batch limit is here, and that's 20. So we can only do 20 NFT fishings per call of this fishing function. Okay, so now we're going to go into this loop that says for, let's see, the token IDs. So however many token IDs you have, token IDs.length means how many do you have. So it's going to cycle through each token, starting with the first one, and it's going to go all the way to the last one and cycle through them one at a time. Okay, so now we're going to go through this little thing. So it's going to say token ID equals the token IDs of whatever this array number is. So it says I equals 0, so this would be the very first token ID would now be run through this. And now it's going to say require owner of this token ID equals the sender. So what this is doing is checking to make sure that the token ID that you put in, you actually own it. And so if you don't own it, this will come back as false, and you'll get this revert error that says QM need to own at least one Floor's Lava. Okay, so the next require is timestamp, which is the block timestamp of this exact transaction minus the last fish time of the token ID is greater than or equal to the phishing interval. Well, what's the phishing interval? Let's go look. So the phishing interval, which was set here, or can be changed there, is set to 86,400 seconds. So that's 24 hours. So if this comes back as false, you get a revert error that says QM wait 24 hours. Okay, so now we've made sure that not only do we own it, but it has been 24 hours since the last time it was used. Okay, now we go to this next variable called chance, and that equals the randomized fish chance function. So now we're going to go into a new function that is going to create a random number here with the following data. Okay, so it's going to use this encoding package with these 3 data points. So you're going to have the block timestamp, which we talked about earlier is the timestamp when the block was mined. We have message sender, which is the person sending the transaction, which would be you, your wallet ID, your wallet address. And then we have notes. Okay, so what is notes here? Let's go see what notes is identified as. So, okay, you went 256, which means it's a number. It's private, which means you can't call it from the outside. And notes. So because it has no initialization, it's going to start off as the number 0. So notes equals 0. Okay, so notes equals 0, unless it's been changed. And I'll show you where it gets changed in a second. So you got your address here, and you have the timestamp, and then this is called a modulus, and this is a 100. So what it's going to do is it's going to take all the 100. It's going to take 100 out at a time of the number, and then whatever's left at the end, after it takes out 100, 100, 100, 100, 100, whatever's left at the end is below 100 will be the number, will be the random number. Okay, so random number now equals random number plus 1. So if this came out at 0, the random number would now be 1. Okay, note plus plus. What this plus plus means is that it means to increment the variable. So this is going to be a note plus plus, which means now notes has gone from 0 to 1. And then it's going to return the random number. Okay, so we're going to return the random number back into the fish function. So now chance equals this random number. Okay, so now so this is saying if this is true, if this part is true, then run this part of the code. If this part is false, you skip this part of the code. Okay, so if chance, the random number that was just generated down here, is less than or equal to phishing chance, and let's go see what phishing chance is. So phishing chance being set at 5 initially, and it could be changed by set phishing chance. Okay, but right now I think we've kept it at 5, and I don't think it's been changed, so we're going to stick with 5. Okay, so now it's going to be a UINT, which is a number. Phishing token ID equals mint, message sender, and 1. Okay, so where is mint? So mint is here, and so we've sent it the address of the recipient, and we've sent it how many to mint, and that's what we've done here. Okay, and so this process, it requires total minted plus the mint amount. So we're adding the 1 to the total minted number, and this has to be less than or equal to the max token supply. So the max token supply being 620. And so if this number equals 621, it will revert and say, nope, QM max supply has been reached. You got safe mint, you got return total minted. Okay, so it's going to return total minted, which would be the number of how many have been minted. And so that will fill in here. And so we're going to have fish token ID, which is going to be the amount that has been minted. Fish token ID plus 1, which now shows the number of the NFT that has been won. Okay, now we're going to do last fish time. Fish token ID equals timestamp. This is setting the timestamp to make you wait 24 hours after you catch it to be able to fish with it. And then you have the 2 events being emitted, which is the fished event and the attempted phishing event. So I can show you that here on Etherscan. What this is this means that under events, you'll see like attempted phishing, attempted phishing, attempted phishing. So these will show the events. This is what emits the event that was created. And the event was created, hold on, let me show you real quick. And the event is up here. So these are specifically important if, let's say, you wanted to track each time there's an attempted phishing event. You could have a listener on it with JavaScript or whatever language you want to use, and you can have it trigger a certain event for you. So that's where those are important, but they really don't matter in the grand scheme of things. I just wanted to explain every piece of this code for you. I wanted you to understand every single line of what is going on here. Okay, so that's what happens if you actually get to mint. The chance is less than or equal to phishing chance. So the other thing is, if this doesn't happen, it's false, we skip over this and it just updates the timestamp for the NFT here, the token ID, and then it emits the attempted phishing event. And then it returns phish token, which is a uint 256. Okay, and so that's where we have that. And I want to show you real quick. It's somewhere down here. Where is it? Okay, and what I want to show you now is I want to show you the events and how the gas is used. So gas, when you put in a gas limit, what you're basically doing is you're filling up a giant tank with gas, and you're saying, okay, or let me better rephrase. When you're doing your gas limit, you're saying, hey, this is my budget, this is my bank account for this transaction. You can pull out of this bank account, but you cannot over withdraw. If you reach my gas limit, which is my amount that I'm willing to spend on the processing of this transaction, then fail. Okay, so do not spend more is what you're basically telling them. So this person put a gas limit of 250,000 to call the function of phish. From there, they called the randomized phish chance function. The randomized phish chance function takes around 80,000 for 4 phishing attempts. So it takes 80,000 of that gas. So this gas limit has nothing to do with gas price. And gas price helps dictate where you end up on the order of getting mined. Gas limit is the lowest form of Ethereum, which is Wei. The lowest format of Ethereum, which is Wei. This is numbered in Wei. And so the gas price is the multiplier of this gas used to process. So I hope that made sense. Please let me know if I can explain that better, because I'll definitely keep trying. So we're going to use out of this tank, out of this bank account of 250,000 Wei for gas, we are going to go run the randomized phish chance function, and we're going to use 80,000 gas on 4 phishing attempts. If we lost and that was it, then boom, it'd be cut, and we'd still have 170,000 gas left, and we would only pay gas for the 80,000 gas times whatever the gas price was. So if that is, say, 10 Gwei, we would pay 800,000 Wei as a transaction fee. Okay. Now, if we happen to get a chance number lower than the given chance number, so if we get a number 5 or below, we would run the mint function. Now, the mint function is going to take, give or take, around 55,000 Wei to process the data in the bytes that it has to process in order to completely run it, which under the mint function, there's also a total minted function, which probably takes like another 5 gas to run, because every byte that you run through the EVM takes a little bit of gas out of your gas limit to be able to, for them to be able to push the information either onto the EVM to change the state of the EVM. So every time the notes changes, for example, it changes the state of the EVM because it changes a storage slot for the contract, and that costs money, and that's where we pay this in gas. Okay, and so then as you can see here, after all that, there was still leftover gas of 109, which they don't ever have to pay. They just paid the 141,000 gas times whatever their gas price was, and then you got your transaction fee. Okay, so I hope this really helps explain to everyone what I meant and really get more into detail of how the contract works, as I don't really know if anybody's done that yet, and I just wanted to make sure everybody understood the details of the contract. And please let me know if there's anything I can do to explain this better. Thank you.